live. AOCD to 13.input. Whenever that happens. Okay, we're live. And basically ready to roll. Hi, my name is Joshua. I'm doing Advent of Code this year, as you probably know at this point. Let's see, I'm doing it in Lua. The problems are out of order now, and they're all shorter than 10 minutes. I got on the leaderboard last night. I'm feeling good about that. I don't know if I'm getting on the leaderboard again tonight. That would be nice. Slow is smooth, and smooth is fast. That is the thing to remember, I suppose. I was giving advice on another YouTuber's video, and I guess my commentary on going fast is slow down like just a little bit, and then you won't make mistakes. And also slow down enough that you can give your brain enough time to parallel process all of the different parts of the problem. And so like last night I started typing this directions map, the very first thing. Can I make it bigger? Okay, I'm gonna make it bigger tonight. There you go. I started typing this directions map very first thing last night, and I was, I could have taken it from a library or something, but I didn't, because I was just typing it and like letting my brain go and think about the rest of the problem while that was running. So anyway, I've made it the display bigger for you, and I'm medium hype. Here I am once again hoping for a half-hour or hour-long problem, but it's just not looking that way right now. I'll say that. I've locked my screen again. This is very embarrassing. At least I didn't do it just as the problem dropped. Come on, GNOME. Hey. Unusually, I had dinner before Advent tonight, and I don't know if that is going to help anything. I did not just get out of the shower after getting on the bike, so we'll see how that affects anything, if at all. And go. Oh, come on. Well, I have a network connection. I cannot seem to hit Advent from my other machine either. Okay, there we go. And I should have data. What the fuck? I don't get it. Oh, I see. I do get it. What the hell's with all of the X's in the input? That took me way too long to understand. Input has been parsed. Cool. So this is the Jesus. How long I have to wait is that. Shit. Cool. 5257. Yeah. It took me just a long time to read that. Find the earliest timestamp. First bus ID departs at that time. The second. Hey, they're prime. They're relatively prime. They're, well, all prime. That sounds useful. That's too big to iterate over. Yeah. We're going to have to do some math here. N mod B1 is 0. N plus 1 mod B2 is 0. N plus 2 mod B3 is 0. I should just use Z3 for this. This seems like a Z3 kind of thing. This is a math team thing also. Just stare at it for a while. This can only happen at timestamps for which n mod b1 is 0. So let's while ts. Okay. Which means we can only add multiples of b1 once we lock in an n. And consequently, we can only lock in multiples of b1 times b2 as we iterate. M. Serrano's got it. He said something in Rot 13. how many multiples to line up. So this is n tot plus b mod this is ts plus b mod times n tot times Ay ts plus bid plus b mod times n mod plus n tot times n mod b mod is 0. Ts plus bid math. This is a modular multiple. This is a modular division problem. Luckily, grep gc. What? I'm not going to do this in time, but I'm having fun, so... TS equals TS plus n times n print TS. Lua 13b dot Lua. 13x dot input. 13b dot Lua. Oh, that's wrong. That's not right at all. Ay, 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 ay. Oh. It's a big number. Did I get big inted? Well, I was slow, but I actually feel really good about getting that right. That was a fun math problem. I'll explain what I did, because I think that this is going to be... I get the feeling that this is just going to be mass fucking slaughter. So let's talk through... All right, so first off, 13... Whoop, this directory, please. 13.lua. This one's easy. Let's just go back to, this is part A here. 13, okay, so part A is easy, and the fundamental thing that's going on is that we're using modular arithmetic, and that really should have primed me for part 2. Actually, part 2 is a lot of fun. That was really cool. And so the idea is that so we want to find the offset into each bus's block. So if we think of a bus with period 3, or let's say a bus with period 4, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So the bus with period 3, so it starts off at time 0, right? And if we say that we want the bus that, or we want to start at time 5 or something like that, we start here. Then we want to find the offset into the block, and so into, that is to say, how long it's been since the most recent bus, and we can do that by finding timestamp modulo bus frequency. And that tells us, so in this case, so visually here, we're looking at this, and the answer is going to be 2, right? It's been 1 tick, 2 ticks since the most recent bus. That's how the modulo operator works. And if we subtract that from the bus frequency, then we know how long it will be until the next one comes around. So that's 1. So I'm sorry, so the bus frequency is 3. And so we subtract that 2 from the 3. There's 1 tick. That's correct visually. That makes a lot of sense. And so that's how long it is to wait. And so, okay, from then on, the question is just find the minimum. Okay, great. No big deal. This one is harder. Yes, this one is harder until I figured out what I was supposed to do. So there's a key insight here. I'm not sure what the key insight is. I like saying key insight, and I'm not sure what the key insight is. I haven't figured out what the key insight is. I'm not sure what the tick is. Oh, okay, sure. That's what the tick is. So there's some periodicity that's going on here, right? And one thing that was really nice, I didn't have to do this GCD thing in reality, because all of the bus frequencies were relatively prime. If we look at the input, in fact, not only were they relatively prime, they were absolutely prime. Factor 1937, 751, 29, 13, 23, 431, 41, 17. Those are all prime numbers. So that's good news, and that was really a dead giveaway as to what was going on there. That I should be considering multiplying combinations of them together. And so the fundamental thing is that all of these patterns repeat with a for any number of buses together, the period of the pattern repeating, so that, like this pattern, right? The period of, there's some up here, there's some down here, then whatever that pattern is. The period of those is, if you multiply all of the bus IDs together, or really multiply their greatest common denominators together. Is that correct? At least, well, what the period is the least common multiple, which is what you get by multiplying their greatest common denominators together. I don't know. It's been a long time since I've done all that sort of stuff. But anyway, the period is the least common multiple, et cetera, et cetera, et cetera. And that's really easy with primes. The least common multiple is you multiply all the primes together. So the period, as I discovered, was extraordinarily big. And so searching inside of that period is bad. But you can divide and conquer. The trick here is that you can divide and conquer, and you can do this iteratively. So it's really easy to find, let's say, the bus with period. Okay, sure. Let's talk about bus 7, right? It's really easy to find the timestamp at which that's bus ID 0. The timestamp at which bus 7 comes around, right? It's 0. We know that. And if we wanted bus 7 to come at timestamp number 1, then we knew it would be 1. Then it just comes at, we just set it to timestamp 1. We can do that. And from then on out, we can avoid affecting the thing that we've already set. We've already set up one of them to come at the right time by adding multiples of bus 7, or of that bus ID, right, of that bus frequency. And the same thing happens once we find a timestamp such that bus 7 comes at the right time and then bus 13 comes at the right time. There we go. Once we find a timestamp such that bus 7 comes at the right time and bus 13 comes at the right time, then we can set up, we can set up whatever more buses that we want at any other time by adding a multiple of 7 times 13. And we will never affect that bang bang combination as long as we add only multiples of 7 times 13, bang bang. And so that's no problem. So let's see. So the fundamental question is, in order to line up one more bus, how many what's the number that you have to add in order to get that? And so the trick here is we'll set up some equations here to illustrate this. This is what I was originally typing. N mod, and N refers to the timestamp. I'm just going to change that to TS here. TS mod bus 1, bus frequency 1 is 0. TS plus 1 mod bus frequency 2 is 0. And so we can make this a little more general. Let's say bus frequency 1, bus frequency 2, bus frequency thing. And bus offset 1, bus offset 2. So the general version of this is timestamp plus bus offset, and then plus we want plus some fudge factor. We'll come back to this fudge factor. We'll fill in this fudge factor, and we'll put in a bound on what this fudge factor could possibly be. Mod bus frequency is 0. Okay? So So nothing heroic has happened yet. All we've done is we've set up an equation for any given bus for what the, so in this case, bus offset is, we want bus 7 to come at timestamp plus 0, right? Okay. Or we want bus 13 to come at timestamp plus 1. So that's the bus offset, is the how far down it is. And so the bus frequency is the bus ID, remember. So nothing heroic has happened here. The only question is, what is that fudge factor? And the answer is this. The answer is, we already know, based on however many buses we've lined up, that when we multiply their bus frequencies together, right? When we multiply their bus frequencies together, we already talked about this, then that is, we can add any number, any multiple of that without messing up any of the previous buses. We can add any multiple of that to the timestamp. So the fudge factor is the thing that we're going to add to the timestamp eventually, right? Has to be of the form n for some n, we'll figure out what the n is, times bus frequency 1 times bus frequency 2 times bus frequency 3, ... So that's a key insight here. And so this is what I'm calling BF1 times BF2 times BF3 for all bus frequencies that we've accumulated so far. I should go look at the YouTube window to see if anybody has asked a question about this yet. No. So that has to be bus frequency 1 times 2 times 3. We're just going to keep accumulating that. And that's what's happening here. Accumulate this bus frequency into the total modulo operator, or into the total divisor. Is that a divisor? I guess it's not. Into the total frequency. Okay. And n tot, let's just replace that with bf tot. Just so that everybody, and then b mod is bf. That's the bus frequency. All right, and then let's just, for completeness here, bus ID, replace this with bus offset. Cool. So now we've come up with this equation. This is how we derive this equation here. TS plus BOFFs plus BF tot times n. Mod BF is 0. Solve for n. Great. And so the only trick here that remains is how exactly to do that. And so I'm just going to split that out to the other direction here. I'm just going to put something, this is basic modular algebra here. And so now I have a x times y mod n equals z, right? And the only thing that happens there is the only thing that's heroic that's happening here is that you can't divide inside modular space, and there's a thing called a modular inverse. You don't have to know how it works. I don't remember how it works. It doesn't matter to me how it works because I wrote it last year and I just copied and pasted it. So I guess that's to my comment, to my point on Sumner's YouTube video from yesterday saying that I don't have a library. I guess I do have a library. It's all my previous Advent of Code stuff. I just copied and pasted my modular inverse and slammed it in. And so the only thing that I have to do there is apply the modular inverse. I take the modular inverse. I have that the residual on the other side here. I multiply the inverse by the I multiply the residual by the inverse, and so that's basically doing the division, right? A modular inverse, an inverse. So any inverse is A divided by B equals C, but the reality is that A is times 1 minus B is C, and so therefore, right, and so if I want to compute this A divided by B is C, then I can multiply through, and so the modular inverse is finding this M that A times inv mod M is C mod M. So that's what the modular inverse is. That's the definition of the modular inverse. Anyway, I multiply through. I found my inverse. I do that modulo the bus frequency. And now all I have to do is add that to my timestamp. Again, I multiply through by the total bus frequency because I don't want to screw up any of my previous buses. And now I've avoided screwing up any of the previous buses. The only thing I have to do is accumulate it, and I'm done. Does this still run? Yes, the answer is still correct. That was a fun problem. I did not get on the leaderboard. I do not care that I didn't get on the leaderboard because it was actually, I don't know, I think this was the first advent of Code Night that required you to be really kind of clever. Now, somebody else said that it is cheesable, and I'm curious. Rot13. Yeah, okay. So the cheesing way to do this, somebody else on my private leaderboard said I used Wolfram Alpha, and yes, that will I was actually definitely thinking of applying that trick. I'm Serrano got to say, I did that. Yeah, right. He forgot to negate the modulo. Yep. Somebody else says I should put Chinese remainder theorem in my utils.py. What is Chinese remainder theorem? I don't think you have to. I don't know. I'll ask somebody later. I don't think you have to do it for this. Yeah, right. Somebody else had said, this is the kind of problem where I expect it to be a lot slower, feels a lot more like, do you remember your college math course than most Advent of Code challenges? That's the case. Anyway, that was a fun problem. I'm glad that I did it. There was a, I don't know, if you like that problem, then you will like day 22 of last year. So anyway, that's how you do it. Here, let me, before I sign off, git add 13.lua 13b.lua git commit -m 13 git push. The code is live on my GitHub now. Thank you. Have a wonderful evening. I will see